Okay, for topic 3, we're going to talk about solving quadratic equations again by completing the square. But what's different here is a is not 1. So that means the coefficient on the squared term is not naturally 1. And unfortunately, completing the square the way we know it by adding b over 2 squared to both sides, that just doesn't fly if a is anything other than 1. So we have to deal with that right off the bat. So the steps here, we have an extra step. First thing we have to do is divide both sides of the equation by a to force the coefficient to be 1. So we have to force the coefficient of the square term to be 1. Okay. And the issue with this, it's not necessarily a hard step at all. It's not. The issue is it can sometimes create fractions, and fractions are they're just more complicated to work with. That's all. Okay. Once we divide all of the terms or both sides of the equation by whatever a is to force the coefficient of the square term to be 1, then we just follow the regular steps for completing the square. So we rewrite the equation to where we have the two variable terms on one side, the constant on the other. And then we add b over 2 squared to both sides. We factor one side, we simplify the other, and then we apply the square root property. So let's look at these examples. So again, the biggest issue is it could potentially create a situation where you have fractions, okay? So the directions say solve by completing the square. So I have 2x squared plus 6x minus 36. Well, I can't complete the square if a, the coefficient of the square term, is anything other than 1. So I'm going to divide, instead of just dividing both sides by the coefficient of the square term, I divide all of the terms by that. It just simplifies a little bit easier in my head. So I'm going to divide everything by 2. Well, 2 divided by 2 is just 1, so that gives me 1x squared. 6 divided by 2 is 3, so that gives me 3x. Negative 36 divided by 2 is negative 18. And 0 divided by 2 is still just 0. Okay? And now I have a situation where I can complete the square. So I want to go ahead and get my variable terms on the left. Well, let me scoot that down a little bit. And in order to get the variable terms on the left alone, I need to address this minus 18. It's a problem. I want to move it to the right. So I'm going to add 18 to both sides. And what happens there is when I add 18 to both sides, the negative 18 plus 18 just becomes 0 on the left, which leaves me with x squared plus 3x plus, leave a little space, equals, well, on the right, I get 0 plus 18, which is just 18, but leave a little space where we can complete the square. Okay? Now, the coefficient of x, that is b. So we need to figure out what b over 2 squared is. Well, in this case, b is 3. 3 over 2 is just 3 over 2. Unfortunately, it doesn't simplify. So we get 3 over 2 squared, which is really 9/4. So I get 9/4 added to the left, and then 9/4 added to the right. And this is where it gets maybe less fun to work with. Okay? So on the left, that's actually the easy side. We want to go ahead and factor the left, and it's always going to factor as a binomial squared. Okay? Now, the terms of the binomial are the square root of the first and last term. So the square root of the first term is just the square root of x squared, which is x. And the square root of the last term is the square root of 9/4. Well, the square root of 9 is 3. The square root of 4 is 2. Okay? And then this sign right here tells us whether we add or subtract in this binomial. Since we're adding up here, we want to add down here. So that's the easy part. The part where it maybe becomes a pain in the behind is where we have 18 plus 9/4. So let's actually do some side work for that. So let's figure out what 18 plus 9/4 is. So we can scroll down here a little bit, and we have 18 plus 9/4. Well, I'm going to treat this as 18 over 1. So what I need to do here is I need to find an LCD. The LCD is 4, okay? So 9/4 already has the denominator of 4, okay? So we're good there, but we do need to rewrite 18 over 1. And in order to do that, I need to multiply top and bottom by 4, okay? Well, let's see here what this ends up being. 18 times 4 is going to be what, 70 something? Let me see here. 18 times 4, we get 2, 3, 72. Okay, so we have 72 over 4 plus 9 over 4 is 81 over 4. Now, that's how we do the 18 plus 9/4 by hand. You could certainly go to the calculator if you needed to and add that there. So 18 plus 9/4 simplifies as 81 over 4. So now we have a situation where we have the variable term isolated in a squared term equaling some constant. We can apply the square root property. So we want the square root of both sides. Don't forget your plus or minus on the left. All right. The square root of x plus 3/2 squared is just x plus 3/2. And then the square root of 81 over 4, well, the square root of 81 is 9. The square root of 4 is 2. So we just get that to simplify to plus or minus 9/2. Now, I do want to get x alone, okay? So the issue is that we need to subtract 3/2 from both sides. Well, 3/2 minus itself on the left is just 0, so I get x plus 0, which is x. And then I like to take whatever I add or subtract and stuff it in front of the plus or minus. That's just the method that I use for this. So I get negative 3/2 plus or minus 9/2. Now, we're not quite done. We still need to figure out each version of x. So we know that x is negative 3/2 minus 9/2, and x is negative 3/2 plus 9/2. Well, as long as your denominators are the same, you just add or subtract the numerators and keep the denominator. So negative 3 minus 9 is what? Negative 12 over 2, or negative 6. And then negative 3 plus 9 is 6 over 2, or 3. So the solutions here would be negative 6 and 3. And there you have it. So that is completing the square where the coefficient of the squared term, unfortunately, is not 1, okay? And if the coefficient of the squared term is not 1, you're generally going to have to deal with fractions. Not always, but a lot of times you're going to have to deal with fractions, which certainly complicates the process a little bit. All right, so that's one example. Let's do one more. This one you're going to just love, okay? So we have 2x squared minus 7x plus 3 equals 0. We have a coefficient on the square term that's not 1. We divide all terms by that value. So we divide by 2, divide by 2, divide by 2, divide by 2. Well, 2 divided by 2 is 1, so I get x squared. Unfortunately, 7 divided by 2 is just 7 divided by 2. And then 3 divided by 2 again is just 3 divided by 2. And then 0 divided by 2 is 0. Okay? We want to get the two variable terms on the left, the constant on the right. So I do need to subtract 3/2. And let's see what that gives us. So on the left, I get x squared minus 7/2 x plus, leave a little space. And then on the right, we get 0 minus 3/2, which is negative 3/2, and then leave a little space. Okay? And then let's do some work here. We know that to complete the square, we need to take b over 2 and square it. Well, b is negative 7/2. So let's go down here and do some side work. So if we have b over 2 squared, that's basically b divided by 2 squared. So in our case, b is negative 7/2. We want to divide that by 2 and then square the whole darn thing. Okay? So that's going to be negative 7/2 times 1/2, right? Do you remember division of fractions? When you divide two fractions, you keep the first fraction the same and then multiply by the reciprocal. Well, the reciprocal of 2 is 1/2. So I get negative 7/4, but don't forget, we have to square the whole thing, which tells me we have negative 49/16. Okay? So this right here is 49/16. That's what I have to add to both sides. Okay? Now, on the left, it's actually really easy to factor this. We've got a perfect square trinomial. The way we factor it is we take the first term, x squared, we take the square root of that, which is just x. We take the last term, which is what we just added, so 49/16. The square root of that is, well, the square root of 49 is 7. The square root of 16 is 4. And then this sign right here tells me what sign I need in my binomial, so I need to subtract. So I get x minus 7/4 squared. Now, the issue typically is going to be simplifying the other side. So we have negative 3 halves plus 49 sixteenths. So let's see what that looks like. So we had negative 3 halves plus 49 sixteenths. Well, the LCD here is 16. Okay, so 49 sixteenths is as good as it's going to get. I need to fix negative 3 halves. So I would need to multiply 2 by 8. So I want to multiply top and bottom by 8. Okay, well, 8 times negative 3 is negative 24. 8 times 2 is 16. And now I can just add or subtract my numerators and keep my denominators. So 24, negative 24 plus 49 is 25 over 16. So this is how the left-hand side simplifies up here. So here we get 25 over 16. And now we're ready to do the square root property. So this is where we take the square root of both sides. So the square root of x minus 7/4 squared, and then we want plus or minus the square root of 25 sixteenths. Okay, well, the square root on the left, when you square root something, or when you take the square root of something squared, they just unravel. So we're left with x minus 7/4 equals, well, plus or minus, and then the square root of 25 is 5, the square root of 16 is 4. So we get plus or minus 5/4. It's a process and there's lots of fractions, but I have faith in you. Okay, now finally, it's been a long time coming, but we need to isolate the x. The issue is minus 7/4. So I'm going to add 7/4 to both sides. And when I do that, 7/4 minus 7/4 is just x. And then that's going to be 7/4 plus or minus 5/4. So let's do some simplifying. So, whoops, I didn't mean to get it completely off the screen. There we go. So we have that x equals 7/4 minus 5/4, and x equals 7/4 plus 5/4. So let's see, for 7/4 minus 5/4, 7 minus 5 is 2. So I get 2/4 or 1/2. And then 7/4 plus 5/4, well, 7 plus 5 is 12. 12 over 4 is 3. So our solutions here finally would be 1/2 and 3. Okay, now I kind of preface completing the square with this is the method that students generally like the least. I will say this, actually completing the square, adding b over 2 squared, not difficult. Completing the square where a is 1 and you're not dealing with crazy fractions, not difficult. It gets a little bit complicated when fractions are involved, and that's fractions can be involved in any of these examples, but it's frequently going to happen when the coefficient of the square term is not 1. So just be on the lookout for this. Now, this right here, this last example, example 3, this is much more what I would expect you to see in pre-calculus. This is much more what I expect you to be able to do in this class. So this is going to give you that foundation, that prep, so that when you see stuff like example 3 in pre-calculus, it's not going to be quite so overwhelming. Okay, so there you have it, solving quadratic equations by completing the square.